So I'm gonna multiply pi by the over 1, multiply by the pi, then over 1. No, 1 over 3 pi. Correct. That's 2/3. Yes.
Yeah. Let's take a look here at our bell work. People did a really good job of kind of synthesizing the information, and then maybe going from information to equation was a little bit tricky, which is fair. We're gonna take a look at this one here and see if we can't make sense of it. Let's start with probably the easiest here. What is our midline in this case? Yeah, -1, but because it's an equation of a line, what'll it be? Y equals -1, right? Centered between 1 and -3. And then what is the amplitude? What is the distance between that midline and our largest or smallest values? That is going to be 2. All right. And then for now, lastly, although we'll see that this is not always the case, but for now, what is the period? How long does it take for me to go 1 full rotation around my circle? It's taking me 3 pi to go all the way around my circle. Thank you. Now, we saw yesterday that our trig functions had this kind of generic form that we could look at. Before we take a look at that, what kind of trig function is this going to be? Is this going to be sine or is this going to be cosine? How do we know that this is going to be cosine? Starts at the maximum rather than at the middle. And so we are going to have some kind of a times cosine of bx plus some vertical shift up or down. Okay. Some of these are fairly straightforward to find. For instance, what is, in this case, our value of A? In this case, our value of A is just 2. And then also not too crazy is our value of K here. What's our value of K going to be? That is -1. Which is just coming from our midline. But a little bit trickier is this value of B. Yes, it's me. Tan function? No, tangent behaves very differently. We'll look at what it would take to start at minimum. It's going to be a cosine function as well, though. And the difference between a cosine function that starts at a maximum and a min is it's going to have a negative leading coefficient. So negative cosine of x would flip it upside down, and it would start at a min, end at a min, versus starting at a max, ending at a max. Yeah. So we'll look at that. Probably not today in depth, but we'll look at that in a little bit. Okay. So we are only missing this value of B. We are only missing our horizontal kind of stretch factor here. What's our normal period? How long does it normally take me to go once around my circle? Normally it takes me 2 pi. But what did I do to that 2 pi to adjust for the fact that we maybe have this value of B here? Well, in this case, we've increased that by another half rotation. But in terms of the equation, we are taking this and we divide it by that B, right? We apply the inverse of what B is. That's that idea that, like, if I'm going twice as fast, it's going to take me half as long. Whatever B is, I'm doing the inverse, I'm doing the opposite to our period in this case. In this case, we know that this works out to be 3 pi. And so here we just need to solve for b. So multiplying both sides by b, I get that 2 pi is equal to 3 pi times b. And then dividing both sides by 3 pi, I get that b should be 2/3. And so my equation in this case, f of x equals 2 times the cosine of 2/3 x minus 1. Questions here with our bell work? So start to finish here, how long does it take to do one full rotation? In this case, it's kind of convenient because it's just maximum to maximum. And that distance is 3 pi. So it takes me from 0 to 3 pi to get all the way through one full rotation. It's a little bit trickier with sine. Sine starts at the mid and ends at the mid, but there are more mid points than in like one full rotation. You're going to hit the midline more than just that twice. And so you have to be a little bit careful with sine just to make sure you get one max and one min before you stop. So like for sine, it would be like once I get to here, I stop. It'll be that distance there. Good question. Other questions here? Would it be helpful to take a look at another? Okay, let's take a look at, I am in the, not there yet. I am in the 6-1 worksheet that I handed out, or the 6-1 notes that I handed out. Let's take a look at, we did example 1. Let's try example 2 here. Exact same thing. Again, ignore frequency. We don't care about frequency. Let's just focus on period, midline, amplitude, as well as the equation for example 2 here. That's up. But you could probably do that. Since you're starting at a point that isn't zero, what would we have to do to our graph to essentially move it over to the starting point? What kind of shift would that be? Horizontal shift, and since it's to the right, you're going forward. And then losing it from the seats and then you're like, whatever.
So it's the opposite of 1/4.
But yeah, you could.
Okay, since you're going like, no, it could. So yes, and you realize quarter term. So
That's one.
which is, with your goal of education to get to that 1/4.
So I agree with all of this. 2 pi divided by pi over 2 is not gonna be 1 now. Because when we multiply by the reciprocal, that's usually not gonna be 1.
Just think about
Otherwise, it's.
what.
Yeah.
And I can read it. Make it or X. Could you?
So is our period 2 pi? Divided by pi.
No worries.
You're basically
Yeah,
going 1/4 of the way to say like.
Solving for I, so you get 1 over b when you do, right? Because b's in their denominator. And then you can take the reciprocal. Yeah. Yeah.
Yeah, I'm sorry.
You hope my phone's
There's like one pack of those.
I'm not sure. I don't want to.
Sign it starts with.
I get it.
Yeah, that's
what.
No.
What's our? Okay, so one is getting a mid, and then what's our distance between that mid and our centimeters?
Still one.
What's the max value? And what's the mid value?
-1.
One. So what's the distance? Two. And then what's gonna be here is how long does it take before we see like one? So if the would take us to. I think that's a lot of.
It is gonna be the midpoint.
So how long does it take until we just need like one goes like?
Yeah.
How long before we start to like?
No, don't be. No.
Yeah, fire two. It's like unique behavior, unique behavior, unique behavior. And I've seen this one before.
What's the example to?
So yeah, fire.
Look, I'm reaching. Reaching now. I also.
2 over pi. But yeah. And then just a quick, that line is gonna be white. So maybe game it for that. But otherwise.
Oh, and
And then how would you solve?
So this continued and.
You could do that. What could we do instead? Just. Multiply by reciprocal. So multiply by 2, divide by 5.
Yeah.
Yeah.
Yeah, it's the wide. Such as like.
I think the way that, yeah, right, they do this, I think you would-
Okay, you take out
X, Y,
You'll calculate it.
Oh, yeah.
No, but I thought you might little.
Right, OSU.
Okay.
I thought it was like 10 and I exited on it.
That's you, midline.
You know,
He's like, it's
Then you
like.
would find the distance.
Okay. Overall, looked really, really good. Very happy with what I saw. What is our midline in this case? Y equals 1, for example, 2. So y equals 1. What is the distance or the amplitude distance between max and mid? Will be 2. How long, this is a little tricky because they gave you a bunch of periods here. But how long does it take before we start to see redundancy? When do we see one loop around the unit circle and then it starts repeating? Yeah, from 0 to pi over 2 is like one distinct image. Max to max or min to min is a good way to do it. And so our period here we said would be pi over 2. And so in terms of our equation, what kind of function is this going to be, sine or cosine? Cosine. So I get 2 times cosine of something x plus 1. And then to find that value of b, that's going to be 2 pi divided by pi over 2, or 2 pi times 2 over pi. I get that b should be 4. All right, questions with our bell work, questions with example 2. How do we feel about going from picture to info to equation? Yeah. So the period is just how long it takes to go one rotation around our unit circle in the context of sine and cosine. Because by the time we get to 2 pi, we have a bunch of repeated images. So like how many, okay, so let's do it this way. On our unit circle, how many times do we hit the maximum value of x? So if I'm looking at one rotation around this unit circle. This is a really good question, and is super friendly. So how many times on our unit circle do we hit the maximum? First of all, where does the maximum value of x occur? Right here. It's like our maximum value of x. How many times does that occur on the unit circle? If I'm doing one full rotation, how many times do I see that maximum value of x? Either once or it depends on like whether you're including the 2 pi or not including the 2 pi. Often you wouldn't include it, but you see it at the start, right? You get it at the start, and then you get it only again right at the end. It doesn't occur anywhere else. How many maximum values do we have between the start and between 2 pi? Yeah, looking at the like graph, that's good. Yeah, I see one, right? Starting out at 1, 2, 3, 4, 5. That means we've gone around the unit circle more than once. In particular, we can think how many times would I have to go around the unit circle? Well, I get 1 if I start, and then that would be 2, and then that would be 3, and then that would be 4, and then that would be 5. That was 4 rotations. So there are 4 rotations between 0 and 2 pi, because we have 5 maximum values that occur between 0 and 2.
Is that what that means this will be fine?
Um,
It says.
yeah, you could use that. You'll see the same thing is true with the minimums. Like you'll have 4 minimums because we hit the minimum 4 times, like it's a 4 rotation. The only thing you want to be careful with is the midpoints, because you get a midpoint in between every single max and minimum, so they're double the number of midpoints. But yeah, that should always work. Yeah, so with sine, it's a little bit trickier. You could still do max to max. Well, let's say it's not drawn. Well, okay, it's drawn and you know, it's just do max to max. But what you're looking for with sine is you're looking for that one complete like that.
Yeah.
Like this.
Oh, so not just like to the next miss.
Yeah, that would only be, yeah, if I'm doing sine, by the time I get to my next y equals 0, I'm halfway around the circle. I need to see 2 midpoints in between start and. Yeah. Good question. Super good question.
Coaches don't even that. It's only one involved. Yes, we know.
Really good questions. Anything else before we add our final transformation? We're ignoring the frequency. Frequency is just the reciprocal of the period. If we know the period, then finding the frequency is like, why are we doing that in addition? No, we're just not going to worry about the frequency. Yeah, we don't care about the frequency, huh? I was going to move on to the worksheet. I can check it. I'll check it once we do the. Yes. Yes. It would be over this as well. It is going to be just completely like on the cuff. I really like those right triangle questions that ask you to list all of the trig. So like all of the sine and the cosine and the tangent, the cotangent and the secant and the cosecant. That was a really good question from our notes that I really like. Just in case that came up. And then it's going to be something very similar to what we are doing. It's going to be in the opposite direction. And what I mean by that is here we're starting with the picture and we're deriving the equation. Yeah. So let's take a look. At our 6162 worksheet here. The whole time. If you're feeling ready for it, we're gonna be learning stuff.
Wait, but.
I will.
That's fine. Yeah.
Oh, is that on the next one?
Yeah, that's fine. Yeah.
That was gonna be.
Yeah. Okay, I'm looking at that.
What are we looking?
I'm going. So let's look at the.
Specifically, I want to take a look at example 4 from this worksheet. This is going to be our segue into like the other direction. In other words, starting with the equation, getting to the picture rather than starting with the picture, getting to the equation. So looking at example 4 here, this is also going to introduce our last type of transformation, which is not going to be anything particularly surprising. This is stuff that we have already seen. So this is f of x is equal to cosine of, I like to use parentheses here. If you just entered that directly into your calculator, it's going to look at cosine of 2, and then it's going to multiply that by x minus pi over 2, and that is not what you want to do. And so just to make it like really, really clear that I'm taking the cosine of this whole thing, cosine of 2 times x minus pi over 2, and then minus 1. Okay. So brand new, not brand new, we've seen this a billion times, but new in the context of our trig functions type of transformation, what is this minus pi over 2 telling me to do? This is to the right by pi over 2. It is the horizontal translation, right? Horizontal shift, right? We do the opposite of what we see. It's like that f of x minus h doing the opposite of what we see from the h. I would love to just call this a horizontal shift and move on with my life. For whatever reason, I have been told that there is one. I am sure that there are physicists who are much, much smarter than I who could explain the exact difference between a horizontal shift in a normal function and what we are about to call this. But as a math purist, I think they're wrong and it's dumb. But we're going to do it anyway because here we are. This is called, in the context of our trig functions, a phase shift. Sure. It's a horizontal shift, right? It's the same thing. We go to the right by pi over 2, which is what we'd expect. That's a great question, right? Like, why would we take something that we already have a word for and give it a new physicsy word? Could not tell you. No idea. Yeah, I think it's stupid. And again, I have been told that there is a difference, but it's one of those things that I just refuse to educate myself on, and I will continue to be mad about it for a very long time until I actually decide to better myself as a person and learn why. It's not going to happen today, though. I'm telling you that. So this is my gripe with physics. I love physics otherwise. This is my gripe with physics, is that we have taken something that is great and simple and is already used in math, and we've decided to make it physicsy for no reason. Except, again, I've been told that there is a reason. I just don't know what it is. It will be wrong. No, you'd be fine. No, that's totally fine. So it's the same thing. Again, okay, that just makes me even more angry at physics. Like, why are we doing this? Okay, sure. Or punch a physicist. One of those two. Well, isn't that lucky? Okay. So let's go ahead and fill in our information here. Got amplitude, period, phase shift, blah, cringe, vertical shift, and midline. Okay, looking at this equation here, what is, kind of a trick question, not really, what is the amplitude of this function? It is 1. Standard, we haven't changed it at all, no transformation that's making it different. It's normally 1, therefore here it's going to be 1. How could I find the period of this function? Where do I find the, what value here is going to correspond to the period? Not the pi over 2. Just the 2 here, right? Period came from, we were looking at sine or cosine, whatever, doesn't matter. Well, it's a different transformation, right? The x minus pi over 2 is the phase shift. That minus pi over 2 is the phase shift. It's not affecting the period, right? If I shift everything over to the right, have I changed how long it takes for me to get all the way around the circle once? No. Right. So the minus pi over 2 doesn't affect it, but that 2 does. And what do I do with that 2 in order to figure out my period? If I'm moving twice as fast, 2 pi over b, well, in this case, b is just our value of 2. So this is 2 pi over 2, which gives me pi. That just is b, right? The format is like a cosine of b. We can now add an x minus h plus k. Where we got 2 pi is the standard period. That's how long it normally takes. Yeah, that's how long it normally takes to go once around the circle. And we adjust that by dividing it by b. Yeah, because b is 2. Yeah. Yeah. Yes, and that's a great way to phrase it, because we're going to look at trig functions where the standard isn't 2 pi, and we do the exact same thing. We take the standard and divide it by whatever it is. Yeah, super good way to phrase it. That's really good. Okay, what did we say our phase shift here was? Yeah. Yeah, right by pi over 2. If you just said positive pi over 2, that's fine. You can also literally write out right by pi over 2. Either way is fine. What is our vertical shift? We are going down 1, and if our vertical shift is -1, then what is our midline going to be? Y equals -1. Yep, always. Well, midline will be y equals whatever that vertical shift is. It would be down 1. Yeah, because it's vertical. Okay, pausing here. Do we have questions with how we have gone from equation to relevant information? Do we feel good about where the amplitude is coming from? Do we feel okay about where the period is coming from? Good about the shifts? It's just like a thing to memorize. It's 2 pi over b. Okay, we've done the legwork. Now all that's left is actually putting the points on the piece of paper. My advice for this, the way I am going to showcase this, I really, really break this down into thinking about what are these transformations doing to the points that we know on the standard rotation around the unit circle, right? I really, really focus on the transformation as a point-wise transformation rather than anything else. And we're going to have 2 different layers of this. One is going to be what's happening to the y values. One is going to be what's happening to the x values. The y values are easier, generally, I think, although ultimately they're both the same. And the x values are a little bit tricky, but also it's just the same level of trickiness of like our transformations with the x values are just kind of generally annoying because you have to keep doing the opposite of what you want to do. Okay, so let's start with the y values here. The points that I care about are going to be the quarter rotations around the circle, which means I only have 3 y values that I need to consider. I need to worry about what is happening. So this is like our information. These are like the actual like finding the points for our y values. I need to figure out what has happened to our maximum value. I need to figure out what has happened to our mid value. I need to figure out what has happened to our minimum value. The very first thing, well, before we get into that, what are our standard max, mid, min? Just untransformed on a cosine or a sine graph? 1, 0, negative 1. Okay. The very first thing that could happen to our y values is an amplitude change, right? If we multiply by 3, that's what our y values are going to see first, is that times 3. In this case, what is our amplitude? 1. Is that going to change any of these y values? No, I'm going to go ahead and still write in that we are multiplying by 1, just so that if we do run into an amplitude later, we know what we're supposed to do here. So this is times amplitude. Which doesn't move us, right? 1 is still 1, 0 is still 0, negative 1 is still negative 1. What is the other vertical transformation that we have going on here? We are going down by 1. And so let's apply that transformation. This is our vertical shift. Down by 1. 1 is going to become 0. 0 is going to become negative 1. And negative 1 is going to become negative 2. These are my new max, mid, min. There are other ways to do this, but I think this is a fine way to do it. You'd also just like start at the mid and then add and subtract the amplitude to get the max and to get the min. That's also fine. Multiply by the amplitude, apply the vertical shift. Which is, you'll notice, is following PEMDAS. We're going to do the opposite for the x's, which is why they're tricky. Yeah. The reason why the x transformations are a little bit trickier than the y transformations is because the x transformations focus around undoing what our function is trying to get us to do. It's trying to fight against what our function is trying to get us to do. And to that end, we tend to follow the opposite of what the transformations are asking of us. So when I see that minus pi over 2, you guys know in your heads, oh, I'm going to add pi over 2. But it also means we undo the PEMDAS, or we go backwards through PEMDAS when we are working here. So if I am looking at the order in which things are being done to x, what is being done to x first, and what is being done to x last? So first we have subtraction, and then we have multiplication, right? First subtraction because of the parentheses, and then multiplication because multiplication comes next. We are going to reverse that order. We are going to first get ready to deal with the times 2, and then we are going to get ready to deal with the minus pi over 2. And we're going to work to undo those values. Now, the 5 significant x values that we care about, the standard x values that go with max, mid, min, are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Which, because this is a cosine function, correspond to which y values. So cosine follows what pattern, essentially? Max, mid, min, mid, max. Which, like, okay, we could apply that here in a second, and we will. But this is why we're doing it, is those are the values that we care about. Normally it would be. Now it's going to be the transformed ones. So it'll start at 0 and then -1 and then -2 and then -1 and then back to 0. Yeah. Super good. Very, very nice. Do we feel comfortable with y, with like the x values that we're looking at? This pattern that we're following? Yeah, it's just the unit circle. It's just the 90-degree rotations around the unit circle. Okay, so we're applying our transformations. We're going to undo what we're trying to do, and we do this in reverse PEMDAS order. So parentheses come last, multiplication will come first. How do I undo the times 2 that we see here that's being applied to our x's? Let's divide everything by 2. Or multiply by 1/2. That would also be fine. What is 0 divided by 2? What is pi over 2 divided by 2? Pi over 4. Yeah, pi over 4. What is pi divided by 2? Pi over 2. What is 3 pi over 2 divided by 2? When I'm dividing by 2, where am I multiplying that 2 in? What can we notice here? Multiplying it into the denominator. So 3 pi over 2 divided by 2 is going to be 3 pi over 4. And 2 pi divided by 2 is going to be pi. How do we feel about our first layer of transformation? Not too bad. Okay. Second layer, we need to deal with the parentheses now. How do I undo the minus pi over 2 that my equation is trying to make me do? I need to add pi over 2 to everything. Okay. So then we're going to do plus pi over 2. 0 plus pi over 2 is just pi over 2. Pi over 4 plus pi over 2, you can match the denominators. This is 2 pi over 4, so we get 3 pi over 4. Pi over 2 plus pi over 2 is pi. 3 pi over 4 plus pi over 2, I get 5 pi over 4. And then here I get 3 pi over 2. Questions about the second layer of transformations? Nope, that's it. I mean, you don't have to. I just find it's helpful to keep track of the work. If you're able to do this in your head, then go for it. I just it's a nice, helpful system to just be able to do it. Yeah, pi over 2 plus 1 pi over 2 plus 1 pi over 2, 2 pi over 2 cancels. Okay, do we feel okay about where I've gotten my x values, where I've gotten my y values? Not horrible. And now we know the pattern. We said cosine follows this pattern. And so we're ready to graph. We said this was pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. This is, we'll call this -1, -2. Well, yeah, I've done this problem before today. How do I know the spacing? They're evenly spaced. So they're very evenly spaced. So for instance, halfway between 0 and pi is pi over 2, and halfway between pi over 2 and pi is 3 pi over 4. Now, if you're looking at this and you're getting these nasty numbers, like what if this was all in terms of pi over 3 or pi over 6, and it's like all in between? Relabel the axes. You are more than welcome to scratch out and write what labelings you want, what spacings you want that are convenient. You don't have to use the ones that are provided. In fact, I will try to give you ones that are convenient if I give you them. Often I will just not give you spacing and you have to define the spacing yourself. And the idea is you just pick these 5 points that you found and that's your spacing. Yeah. Well, you could figure out like about where they are, like you could guess it. But again, you can just like scratch it out and write your own X values. That's totally fine. That is totally fine. So again, for everyone to hear, because I've had a lot of people being like, how on earth do I figure out how this spacing? Oh, you have the benefit of you don't have to fit it to the graph. I'm giving you that benefit as well. If you do not like the spacing on your x-axis, change it. Make it convenient for yourself. I do not want the hard part of this to be figuring out, well, where in this does pi over 4 land and where does 5 pi over 4 land? I don't care about that. Make the spacing convenient. Yes. I mean, you need to know like where the x values are and things like that. It's important to know like what your x values are. Yeah. Okay. What was the order that we said cosine follows? Max. Yeah, max, mid, min, mid, max. If we could refocus here. My chime's all the way over there. I don't want to walk over to it. Oh, good. The threat of it is just as good. Just as good a motivator. Well, you want to like connect the dots. But no, I only need you to graph one period. Just this. Yeah. Just one period is fine. So connecting the dots. I get something that looks like this. That's fine. I'd prefer a little attempt at curving it, but yeah, it's fine. I've been graphing cosine so much better than sine this year. I don't know why. Normally it's the opposite. But, it's fine. I said fine, not fun. I do find it fun though.
If you say it so many times out loud, then you'll believe it.
It's true. 7 times, and then it's burned into your long-term memory. Then you can remember it. Oh yeah, I was.
Don't believe it, probably. I'm gonna start like. That's like pulling out an expo marker. What did they have? This bird just check my word. Right.
Are we doing more of these today?
Yeah, we'll do number. We're gonna do.
Okay, so.
I want you guys to go ahead and try to get started on example 5 here from that packet. If you want to start converting the x values and the y values after you filled in the information, that's great, go for it. But if you're like completely lost on how, well, try it. See how far you're able to get, and then we'll go over this.
What is that solving for? Oh, that's the periods. So.
E is decided to. And so 2 y divided by 2. Yeah, it's fine. Now, you'll notice I didn't use the period. Like, the period is pi, right? The distance between pi over 2 and 3 pi over 2 is pi. I didn't use that though. what we do to the period models what we're about to do. So like the thing that we do to the whole space, where like think about like we're taking something that fits into.
So that's
And
gonna be a
working across it,
multi-line.
and you put it on. So I'm putting on the figure.
We have to sort of.
Exactly, it's constantly, yeah, what we did to the period, what we did to the entire stretch, you could also think about just doing to each individual.
So it's like amplitude is one.
Oh, wait, yeah, so it's being.
I get the basics, I get this.
I usually know.
The basic.
Oh, yeah, hold on.
That's fine.
I did it last year. I never know.
It doesn't.
I just followed.
Yeah, I'm watching.
I'm done. I don't want to. It gives it to you. The amplitude is like the multiply the beginning, so there's some that really worse.
It's the same as the midline.
So like.
Yeah, I'm just checking the midline, so midline is wide, it's the vertical shift.
60.
Period is related to the pi over three, but it's not.
Yeah.
There's not quite sure.
That the 2 pi.
Two pi divided by.
Oh. So that, right, that's fine, okay, maybe the Y values. The Y value is normal in the spring part, on zero, and then
6 months.
max is usually, what is usually the max? I can't remember any of this. 5 over 5.
This looks good. What is this gonna simplify to?
Special. Okay. Which is 1.
Wait, do that.
Plus. Why can't I do wrong? Literally pi over 2. It is 3 pi over 2. Wait, right? Like, what do you think about it? What are the starting price again?
0, pi over 2, pi, 3 pi over 2, and 2 pi. So it's every 90 degrees. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Yep.
Dividing. Yeah, yeah. Well, I mean, I would say that we're dividing. So it's just, I I have to match the denominators, but I think something like it's. We're talking about. And they ask me that. It's really hard. Fancy thought though, but it's less. That would be. Always. I over 2 divided by.
So this is the value.
You know, he uses storage. Pi over 2 pi. There's 3 over 2. One very bubbly. And that's. But it's 5 pi. You know, that's. Oh, we know the. But honestly, yeah. Divided by. 9 over 2. So there's always 5. Like maybe. Like you're right, I'm also gonna. You're sitting on your. 6 over 5. 6 pi over 5. 6.
When you work.
Stand on this.
Maybe never. It's not like a. It might just be.
Why do I want to do 6 over 2 pi then?
Yeah, I could also be wrong, but.
That's
Oh, they don't. That's just what I.
2 pi over 6 gives you the pi over 3 causing b.
Wait, where are you?
But you don't do that because you're already there.
Oh, yeah, I did that. I guess I've done it twice.
All right.
Like that. That's really annoying. Yeah, you do have to. Addition is the fate of systems.
Okay. Let us take a look at example 5 here, see what we're able to do. Again, just kind of going through the information here. What is the amplitude of this particular function? It is going to just be 1. Nice and boring. How do I find the period of this function? 2 pi divided by pi over 3. But dividing by pi over 3 is maybe a little awkward. So what could we do instead of dividing by the fraction? Multiply by the reciprocal. I get that this is 6. 2 pi times 3 over pi, giving me 6. What is my phase shift here going to be? Okay, we could say negative 3 over 2, or what else could we say? 3 over 2 to the left. Make sure you don't mix these two. If you say negative 3 over 2 to the left, then you have just told me 3 over 2 to the right. So, don't turn around after you've already turned around. What is our vertical shift here? 2. And what is our, you could even think of this as like 2 up if you really wanted to. And then what is our midline going to be? Y equals 2. Very nice. Let's start with the y values because there are less of them. We've got our max that we have to worry about. We've got our midline that we have to worry about. We've got our min that we have to worry about. Normally 1, 0, negative 1. What is the change that we have to apply first? Amplitude, which is just times 1, so that doesn't do anything. And then what is the change that we apply next? Plus 2. So I get 3, 2, and 1 for my max, mid, and min. Okay. Let's take a look then at my x values. So normally this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. What is the first change that we apply? Say again. Well, what are we doing to each of these first? Multiplying by 3 over pi. Dividing by b. Divide by b first. All right, so first divide by b, then add h. So first we are going to divide by pi over 3, which I like the reframing of instead multiplying by 3 over pi. I think that's going to make our life a lot easier. When I do this, I get 0, 3 over 2, 3, 9 over 2, and 6. I want to pause here for a second. So this way is great. If you are looking at this and you're like, okay, it's a lot of writing, but like I can manage this, it's not too bad. Then keep on going. This is great. I do want to highlight something here though, and it's kind of interesting. We haven't used the period. yet. Like we're finding it and cool, but we haven't been using it. And it should be showing up somewhere here. After my first transformation, what can we observe? One, there's no pi, but in particular, the 2 pi that was originally my period has turned into 6. And 0 just stayed 0, right? That was always just like, before we apply any kind of shift, nothing that we do to 0 is going to move it. What can we notice about 3? Where's that 3 coming from? It's half of a rotation. This is halfway between 0 and 6. Where is 3/2 coming from? It's halfway in between 0 and 3, or a fourth of the way between 0 and 6. And then where is 9/2 coming from? Average of 3 and 6, so halfway between 3 and 6. This is like 3/4 between 0 and 6. That's another way you could find the first layer of transformation here. Is you could look at, okay, I have my period. That means I'm going from 0 to 6. Halfway in between that should be what pi was. So now that's going to be 3. Halfway in between 0 and that middle value will tell me what pi/2 was. Halfway between that middle value and my maximum value will tell me what that 3/4 of the way was. Yeah, I mean, either way is fine. They both will get you there 100% of the time. Yeah. So whichever you find easier, go for. Which is why I'm just highlighting both. I will say I moved away from this because I don't think people tended to find it easier, but I am now going against my better judgment and showing it again. Do with that what you will. Okay, and then we need to apply our shift. So what's the second layer of transformation that we're going to apply here? Yeah, we're going to do the minus 3/2. I get negative 3/2, 0, positive 3/2, 3, and 9/2. Yeah, worked out pretty nicely. Graph looks like this. I guess the one thing I should note here, because this is sine, what is the pattern that we are going to follow? Very nice. Yep. This one could be helpful to think of in terms of decimals as well. This is like negative 1.5, 0, 1.5, 3, 4.5. Not a bad way to think about it either. Yeah. And you get something like this. All right, questions with our graphing here? Sine and cosine. we're gonna get back to it. We're gonna do that once we get back from break. We need to test Friday, the week after we get back. We'll do, so. We'll do practice on sine and cosine tomorrow. Well. Yeah, I want to give you guys some time to do some practice here. It'll either be Thursday or Friday next week. I'm sure. Yes. Probably Friday. All right. Stop this.